Alright, so what we're going to look at is what's called a joint variation. A joint variation basically in some way, shape, or form combines direct and inverse, or has a regular inverse that's a little different than the normal one, or a regular direct that's a little different than a normal one. So we're going to look at a couple of explanations of these. Again, this is joint variation, even though I know my pen kind of sticks here and there. So let's say I had the phrase y varies directly with x squared. Or I'm going to look at a couple of them here. Let's say y varies, pen is sticking so bad, I'm sorry, varies inversely with the cube of x. Or let's say m varies directly with p and inversely with h. Let's say n varies jointly. I'm sorry, I know that does not look jointly. Even my varies doesn't look like varies. Sorry. Alright, so let's say n varies jointly with p and I, let's say. Okay, so what we're going to try to do with these is just write out the equation to them. So if you need to pause the video to catch up, by all means. Alright, so the first one says y varies directly with x squared. So this is considered a joint variation because it's not just a regular direct. There's something different about it. So this one would be y equals k times x squared. Directly pretty much just means that it's multiplied to the k value. Inversely is the one that you divide. So like the second one would be y equals k over, because inversely means it's at the bottom, of x cubed. So those are, again, considered joint because they're not exactly the same as just a regular plain direct or inverse. So this third one, m varies directly with p and inversely with h. So this is another joint. This one actually combines both. Directly with p, so that would look like this. Now the inversely part just means you're going to divide by that part, so that's inversely with h. Okay, and that's kind of probably what you'll see in your exam, is something more similar to that. You may have one that says the word jointly in there. If it doesn't say direct or inverse and all it says is jointly. It's basically the same thing as a really big direct. Everything just multiplies to k. So, oh, you know what, I just realized that one is an m. There you go. Sorry. I was changing variables around in there, trying to make sure that you don't get used to it being x and y. It doesn't have to be x and y. So jointly with p and I just means it's a really big direct variation. It would look something like that. Alright, so we're going to look at, this is kind of more of what your homework has in it. It's going to have some mixture into there, so if you need anything from the screen, go ahead and get it. Alright, so hopefully this, when I write this, it will go through nicely. Let's say z varies directly with x and inversely with y when x equals 6, y equals 2, and z equals 15. Right, and we want to find z. When x equals 4, and y equals 9. The first thing you want to do with this is you want to get this thing set up correctly in there. So z in this case is going to vary directly with x and inversely with y. So we want to make sure we set it up correct. So z is going to vary directly with x and inversely with y. So in this one, it's going to have an x and a y that go together, or x, y, and z that go together, because we have to find our k value. There's no quick shortcut to finding k for these, because every single one is different. There's not one that's exactly the same as the other. So we know that x is equal to 6, y is equal to 2, and z is equal to 15. So we just plug them all in. So 15 equals k times 6 all over 2. So you just want to work your way through and solve for your k. In this case, if you see it right here, 6 does divide 2 evenly, so that actually is the same thing as 3k, and that means that my k has to be equal to 5. So if it just asks you for what your equation is, which is most of what your homework is going to ask you to do, you just have to find the equation. Now this one does ask you to go a step farther. It says find z when x is equal to 4. So we're going to plug in 4 in for x. And we're going to plug in 9 in for our y value. So this one becomes 20 over 9. Again, you could give me the decimal to it. And in this case, that comes out to 2.22. Okay. So just kind of make sure you can do those combined ones. Okay. The only other thing that we looked at on that Friday was we looked at coming up with the equations of inverse variations from a graph. So we're going to look at a couple of those. I'm going to hand draw these things the best that I can. I gave the class computer drawn graphs, so let's see how this goes. Okay, so I'm going to change the screen. Let's do this, and I'm going to switch it over. Okay, so we want to be able to come up with a nice graph. So normally when you have something like this, you're not going to have, I'm going to kind of give you some points on here, I guess, that will look decent as we're going through and finding them. But normally you would just be able to look at the graph and find these kind of nice coordinates, but because I'm going to have to hand draw this thing, I know it's not going to come out pretty. So, let's see, that's a point where it's going to hit nicely. That's a point where it's going to, oops, come on now, nicely. Another point where it's going to hit nice, come on now. There, hit nicely, and then another place where it's going to hit nicely. Okay, so I'm going to try to connect these the best that I can. This is what an inverse function is going to look like. There we go. Okay, so this is what an inverse graph looks like. Normally when you look at these, you would look and just look at where it hits those grids just perfectly. And if you remember correctly, in an inverse function, in order to find your k value, which is all you need to get your equation, is it just x times y. So it doesn't matter what points you pick, you just pick a point, any x and y point where it hit the graph nicely. Again, I had to hand draw mine here, but let's say I use this one. This one's at 3, 1. My k value would just be the x value times the y value. So my k is 3, which means that my inverse function is y equals 3 over x. So with an inverse function, I could have picked any of those 4 points. All of them would have given me the same k value of 3 and made it easy to find my function. I didn't add any of those to your homework. I haven't written that homework yet. I may try to do that so that you can come up with your equation a little easier.